All right, so we said number 5 where we left off. All right, so Robbie opens an account at a local bank by depositing $100. The account pays 2.4% interest compounded weekly. He deposits $100 every week for 3 years. How much is in the account after 3 years? So again, I need you to start thinking about which formula. How do you know which formula is what? Okay, it's definitely not simple interest because you don't see those words. You didn't see APY in there. And then all of them are talking about compounded, so all those formulas use compounded, so you can't just go by that word. But I'm putting money in, what is it, $100 every week. So it's periodic, right? I'm constantly putting money in. Now, how do you know whether it's the future value formula? I know that's the section we're on, or the present value. It is the section we're on. When it comes time for your test, though, they're going to all be intermixed. It's asking, yes, in this problem it gives you the formula. But Casey, yes, you're right. It's asking in the future, in 3 years from now, how much money am I going to have? It's asking in the future, how much are you going to have? Okay? All right, so if I'm looking at this problem, let's go ahead and plug numbers into my formula. So the balance equals, I'm starting with $100, and then 1 plus my rate, 0.024, over, it is being compounded weekly. So how many is that? 52. Oops. All right, so then it would be 52 times, we're looking at 3 years, minus 1, all over my rate, 0.024, over 52. All right, so we're going to grab our graphing calculators, or Jared's going to attempt to do it on his own. All right, let's see what you get, Jared. So let's all try, and then we'll see what Jared gets. Jared, I agree that you can do it on there, but I don't see why you'd struggle when you don't have to. It makes it more fun. Okay, whatever floats your boat, I guess. So again, guys, please make sure you're practicing this, because if you type it in the calculator wrong, I mean, you're going to get it wrong. All right, so double check what you got with what I got. I got $16,171.46. All right, anybody need calculator help? Who did not get that? All right, part B. What is the approximate balance after 2 years? So again, now, guys, do you know how to, like, yeah, to just change things? Yeah, if you just arrow up and highlight it and hit enter, it brings it up again. So then you can just arrow back in and just change the 3 to a 2. Nah. If you just hit arrow up until the entire equation is highlighted, and then hit enter, it brings it up so you can actually like edit it. So now you can arrow over until you get to the 3 and just change it to a 2. So that one would give you $10,651.12. All right. Guys, let me add on another question to this. Let me add part C. How much interest is earned? Now, the reason I'm asking is it's going to take us a little bit of work to do this. Because normally I just take final balance, right? And then you subtract how much he actually put in. But we need to figure out how much he put in. So let's do after 3 years. Let's just do the 3 years one. So let's do it for 3 years. So how much does he put in? $100. He does $100 every week. So how many weeks does he do this? For 52 weeks. For how many years? 3 years. Right, so we need to figure out how much he actually put in. So 100 times 52 times 3. So he put in 15,600. So how do you figure out how much is interest then? You subtract that. So you would take the 16,171.46 and subtract how much he put in. I added on a part C. How much interest is earned in 3 years? Yeah, I added that on just because I know it comes up a lot. I want to make sure we're used to seeing it. So he put in $100 for 52 weeks a year. He did that for 3 years. So that's how much he put in. That's how much we found out that he actually had in his account. So if we subtract his balance minus how much he put in, that will tell us how much interest he actually paid or earned. So he earned $571.46 in interest. You know, that's not terrible though. It's 3 years. So that's free money, right? I like free money. All right, questions on this problem? Good. All right. Suppose $600 is deposited into an account every quarter. The account earns 5% interest compounded quarterly. What is the future value of the account after 5 years? Now this one's nice. It actually said, what is the future value? That made it nice. But if it didn't, you could look at that and be like, okay, what's the value of the account after 5 years? So I wanted to look into the future to see how much money I have. Okay? So again, let's look at our formula. Let's write it down. So B equals. How much am I starting with? 600. 1 plus my rate, 5%, 0.05, that's a good interest rate. Compounded quarterly, how many times is that? That is 4, good. 4 times, and we're talking 5 years. All right, so this is another calculator. Jared, good luck. See if we can figure it out. Are you getting faster at putting the fractions in? So double check what you got. I got $13,537.79. How'd we do? Good? Got that? No? Oh, hon. You need to use the fraction button in here. And you're missing a parentheses. You're missing a parenthesis. After the 600, you should have 2 parentheses. He's figured it out, hasn't he?
So if you have one too many, your answer comes out as 0. If you have one too less, it's a syntax error. So as long as I know if I hit a 0 or a syntax error, I can just go back one. Solve for 0 for this, please. Just be freaks.
That would be kind of funny. All right. Now, part B, what's the approximate balance after 3 years? Let's arrow back up to that equation. Make your life easy. Let's change that so it's 3 years. And see what we get. So I got 7,716 and 22 cents. Yes, good. How are we feeling? Tired. Okay. All right, though. All right. Last section, last new formulas. Yeah, I was being serious. There's birds behind you. There's birds. All right, guys. So get your green papers out in front of you because we're going to make some notes on these too. So present value. So these are both listed as present value formulas. And again, sometimes in my mind I think of these backwards. So present value is the current value of a deposit that's made in present time. So I'm depositing money now to see so I can have a specific amount in the future is what we're looking at. So what does it mean to calculate the present value of a single deposit investment? To calculate how much to deposit at a specific interest rate in order to have enough money in your account later to meet a given expense. So for example, how much should I deposit into an account now so that I have $10,000 in 20 years? Right? Maybe you're trying to save for something in particular. Like I want to remodel my kitchen. So how much do I need to put away now so that I have enough 5 years from now so I can remodel it? Kind of thing. Okay? So in my mind, this one gets a little tricky because I'm like, oh, I want to see how much I have in the future, right? But no. How much do I deposit presently, right now, so that I can have that? The future one is asking how much money will I have in the future? Okay, so I know these can be a little tricky. I have not. I need to, though. All right, so guys, on your green papers, when it's talking where it shows the single deposit investment, if I were you, I would maybe write down this example, right? Example, and then write it down. How much should I deposit into an account now so that I have $10,000 in 20 years? That is a present value of a single deposit investment. So I'm just, hopefully in your mind you can keep straight single deposit and periodic deposit, right? Single deposit, I'm putting one lump sum of money in now, and I just want the interest to accrue to give me how much I need. Okay, so it's nice to see the formulas with an example maybe next to them so you can kind of be like relate it back to that. So how much should I deposit into an account now so that I have $10,000 in 20 years? And then what does it mean to calculate the present value of a periodic deposit investment? So think about that one. To calculate how much to save on a regular basis at specific interest rate in order to have enough money in your account later to meet a given expense. So how much should I deposit monthly in order to have $7,500 in 4 years? So see the difference. The one is single, so I'm only putting money in once. Right? This one is how much should I deposit every month so I have $7,500 in 4 years. But again, these are called present value, not future. Even though I'm kind of looking towards the future, I'm looking at how much do I put in now, presently, so that I can have that much then. The future value equation is how much money will I have in 10 years. You have no idea how much it is. You're trying to figure that out. Okay. Do you see why it gets a little confusing, though, with the future and present? So I think it might help you to have an example on there so you can kind of reference that. Good? Yes? Yes. All right. Wonderful. Does what? Yes, we'll talk about that today. Yeah. All right. So present value of a single deposit, there's your formula. Again, they all look very similar, right? But notice the difference here is it's got the B is inside the formula. Before it was always B, or the balance equals yada, yada, yada. But now, this is my ending balance. So I want to try to raise $10,000. So $10,000 would have to go here then, because that's how much money I'm trying to save for. So P then is your principal or original balance, your present value. And then all the other stuff's normal. All right, so Mr. and Mrs. Johnson know that in 6 years, their daughter Anne will attend state college. Are you going to state college, Anne? Okay. Are your parents Mr. and Mrs. Johnson? No. All right, she will need about $20,000 for the first year's tuition. Oh, that's really expensive. All right, how much should the Johnsons deposit into an account that yields 5% interest compounded annually in order to have that amount? Notice it says they're just depositing just one time, right? How much should they put in? It doesn't say how much should they put in weekly, how much should they put in monthly, just one time. That's why we're using the single formula. Again, also trying to think about, because you're going to have to determine, is it the future value one or is it the other one? Like, how do you know which formula to use? How much do I put in now so that I have that much later on? So how much do I put in presently to have that in the future. All right, so filling this in. So I'm trying to figure out how much I need to put in there. So what's the ending balance that I want? 20,000. I want 20,000 when I'm said and done. Divided by 1 plus my rate is 5%, so 0.05 over n compounded, how often? Compounded what? Annually. So how many times a year is that? Once. 1 times, how many years? 6. It is 6 years. The 6 is in there, it's just not where you guys thought it was. All right, so grab your calculators, type it in, let's see how much they need to put in. I'm thinking to save 20 grand, they may want to start it a little sooner than 6 years out. What do you guys think? Maybe they make good money, but I don't got their kind of money. So I found $14,924.31. So do you guys got an extra like 15 grand sitting around? Yeah, I don't either. Now, am I good? 100% full credit? Read the problem. It says round your answer to the nearest $1,000. So what would you round to? 15,000. This rounds up to 15,000. Yeah, so they need to put in like 15 grand so that in 6 years it actually does grow to 20,000. Okay? Right, that's only 1 year. All right. Jada just graduated from college. She wants $100,000 in her savings account after 10 years. It's a lofty goal. How much must she deposit in that account now at a 3.8% interest rate compounded daily in order to meet that goal? Round up to the nearest dollar. So she just graduated. She wants to put in money right now so that in 10 years, yeah. How often does she put in? Right. Yeah, she's crazy. But how often does she put money in? She put just once. It just says she's putting money in once, right? All right, but again, I need you to recognize to tell the formulas, right? How much does she put in now so that she has 100,000? So I'm trying to figure that much out. So 100,000 is your ending balance. Compounded daily. What's daily? 365. How many years? 10 years. All right. I mean, I'd love to have $100,000 too, but it's just not going to happen. Yeah. Is it worth it? Whew. How much does she have to put in? $68,387.49. So round to the nearest dollar. Where would you round? 387, right? Because that's 49 cents. So there it is, rounded to the nearest dollar. I don't know about you, but just straight out of college, I didn't have $68,000. I graduated college, what, 14 years ago? I still don't have $68,000. Yeah, that ain't happening. All right. So then the other one is the present value of a periodic deposit. Look at that formula. Aren't you happy I'll give you a formula sheet, though? Can you imagine trying to memorize these formulas and keep them straight? And underline. I can prepare you so you know which one to use. All right, guys, again, this is again looking at how much do I put into my account now so that I can have a specified amount in the future. And, you know, that might be something else to put on your green paper, guys. You want a specific amount of money in the future. Like, I want 10,000 in the future. I want 20,000 in the future. Like, maybe make a note, guys, on the present value ones. I want a specific amount in the future. Not just, how much am I going to have? It's, I want 10,000. I want 1,000,000. Whatever it is. That's a whole other conversation. All right, example 3. Nick wants to install central air conditioning in his home in 3 years. He estimates the total cost to be $15,000. How much must he deposit monthly into an account that pays 4% interest compounded monthly in order to have enough money? Round to the nearest $100. So again, this is a very real-world thing that you might do as you get older, right? I want to put in new central air conditioning. Figure out how much it's going to cost, and you got to save for it. All right, so P equals. So my balance I want is 15,000. The rate, 4%. Compounded monthly, so how often is that? Be 12. Over 1 plus 0.04 over 12. 12 times how many years? 3 years minus 1. Oops. All right. I haven't typed it in yet. I was writing it. Give me a minute. That doesn't sound bad. Just remember, he's putting it in every month. You're finding out how much he should put in every month. So that sounds reasonable. Over 12. 12 times 3 minus 1. Yep. So $392.86. All right. So guys, I know, like Leah here kind of panicked when she got her answer, like $392. Like, but think about, he's putting it in every month for 3 years. So I mean, think about how that's going to add up. Every month he's putting almost $400 in every month. Okay, so that's going to add up to give him the $15,000 in 3 years. So it said round to the nearest $100. What would you round it to? 400. Yeah, so if he's putting roughly $400 a month into his account every month for 3 years, with interest and whatnot, he will have earned the $15,000. Okay? So every time you get an answer, think if it's reasonable. If you had gotten like $6,000 for an answer, so you're going to put $6,000 every month in an account to try to earn $15,000? But I mean, think about though, is it reasonable? Think about what you're actually doing. All right, last one. Sunny needs to repay her school loan in 4 years. How much must she semi-annually deposit into an account that pays 3.9% interest, compounded semi-annually, to have $100,000 to repay the loan? All right. So again, I'm looking for a specific amount of money that I want to have accumulated. So that's why you know it's the periodic one, or the present value, present value, because I want a specific amount. All right, so let's go ahead and write out our formula. We want 100 grand. Have you guys gotten to the point where you're no longer writing down the formula? What's semi-annually? That's twice. All right, that's what the formula should be. So let's go ahead and type it in and see if that's actually what we get. Oh, I typed something in wrong. Oh, I got an extra parenthesis in there. That'll do it. There we go. $11,671.58. So think about it. Semi-annually. So how often is she putting that in? Two times a year. If she puts in, what, a little over 11.6, then she's going to have $100,000 in 4 years. Twice a year she's putting that in for 4 years. It makes sense. Because she's also earning interest, which is good. All right, so that's your new formulas. So again, keep in mind as we're looking through this, so I'm going to give you homework. I'm going to give you homework over 3.7 and 3.8 today. It will not be due until Friday. I will leave you some things to do the next 2 days as well. So don't just put off what I'm going to give you today until the next 2 days, because I'm going to give you more stuff then. It won't be a ridiculous amount of stuff, though, I promise.